So hi guys, I'm Serena from AMC Learning Program, and today we're focusing on the functional equations appearing in math competitions. So what is a functional equation? It is any equation where the unknown is a function, and we're searching for the properties of the functions by analyzing the condition the problem gives us, and it is pretty common in Olympiad math. Here are some basic definitions that you need to know before we progress. These are pretty basic, and I think most of the audiences know what they mean. Today, we are basically introducing the substitution method, for it is one of the most helpful methods in solving for unknown functions. And the most natural substitutions are 0 or 1, because they're like pretty natural numbers. And we think of them when we want to take some special values. But we can also substitute other variables, and we will see some examples later. All right, so let's jump to the LaTeX. So first, the problem is from the IMO shortlist 2090A1. And let they be the set of integers determining all functions f from z to z, such that for all integers a and b, f2a plus 2fb equals ff(a plus b). So we can first think for some while before we begin our walkthrough. So I think the natural things to think is that you can substitute like 0, because it is a pretty natural thought, and many problems actually uses it, pretty common. So we write like substitute a equals 0, then we will get f0 plus, oops, sure, right, $sign. F0 plus 2fb equal ffb. So actually, now we actually pay attention to the right hand side of the equation, and from the equation we write about, we can actually rewrite the equation into f2a plus 2fb, oops, call f0. It's actually just like substitute the b in the above equation using the a plus b. So it is actually a substitution using other variables. And after it, we can substitute b with 0. Then we get f2a equals 2fa minus f0. It is pretty obvious and do not need any further explanations. So actually what we now get is that fa plus fb equals fa plus b plus f0. It's like if you substitute the equation we get in 3 using both a and b, you can get the equation pretty easily. So now we can assume a new function hx into fx minus f0. And it is pretty obvious to know that a plus hb equals h a plus b. Using the equation we get about, we know it is true. So from this, we can know that hx is actually linear, and its equation can be written as hx equals cx, where c is a constant. And moreover, we know actually fx just equals cx plus f0. So Now we want to like find what's the value of f0. We get it. The problem is basically done, but I will just left it for the audiences because I do not want to leak everything like once. And yeah, you can try to find the f0 because it is not hard at all. And the second problem is from Vietnam, TST, and it requires us to find all functions of z to z satisfying the condition above. I mean, after you look at the equation, it is pretty natural for us to guess the answers, right? And so we write here, first, let's guess the answers. And the answers is actually like pretty easy to guess for fx equals 0 and fx equals x and fx equals full x can all work. But these are just our basically guess and we'll progress later. So it's time to do some substitution and pretty natural to do. X equals y equals 0 equals z. So we basically get stuff like f0 equals 3f0. So we know that f0 equals 0. You can also try some like other substitutions, but what I notice here is that fx is actually an odd function. But like, how do I know that? Still substitution. You can substitute y using like minus z and minus x and z equals 0. And then you can actually get that f full x cubed because full fx cubed, and it implies to us that actually fx is an odd function. So, I mean, why do we have to know this? Actually, we notice that here is the z symbol. So it reminds us that it works for all integers. And so the odd function makes us only have to prove one half and the other half can work vice versa. All right, so let's substitute more. And so what if we take xyz as 1, 0, 0? And the equation actually becomes that like f1 equals f1 cubed. So we know there are basically 3 possible values for f1, and they are 0, 1, and -1. So we actually realized that the substitution of 1 and 0 is pretty useful, and we can like do more about it. So we continue our substitution. For this group of substitution, we can actually get that f2 equals to f1. And if you substitute more, for example, you can do it like 1, 1, 1. Then you gotta know that f3 equals 3f1. So from here, actually, we can like guess the answers, and we want to prove that fx equals xf1 for all integer x. I mean, this is something that we get from our substitutions and guessing answers. It is not guaranteed correct, but basically correct. And here you need the important lemma, which states that for all integers x, or we can write x cubed into the sum of five integer cubes, which are strictly less than x. Actually, I should not write which, just write whose absolute values are strictly less than x. This is a pretty important lemma, and after using it, the problem is basically done. So I want you to prove this lemma on your own, because I've helped you till now, and the lemma is the only thing that you need to solve the whole problem. So now we assume that you prove the lemma. And after you prove the lemma, you just need to use induction, and we're done. So basically, there are two questions left. The first is, what is the value of f0 in the first problem? And the second is, how can we prove the lemma here? All right. Thanks for listening.